Welcome for the second class of how to rotate about accurate pivot point in UE4. Let's open the UE4 engine. And load back the robot map of the class 1. Today we will write a C++ class to generate a hierarchy of the 6x robot. Use Visual Studio C++. Let's open the robot tutorial 2. The robot showing here. Okay. First, pick C++ classes. Right-click the mouse button. Pick New C++ class. Let's create a class of actor. Next, located at D drive on your projects, Robot Tutorial 2. Source, Robot Tutorial 2. And the name we give robot rotation. Create a class. Will take several minutes. And this class will create default sub-object of scene and static mesh from fn0 till fnt. And we use U property. So after compiler success, the FC editor will showing the hierarchy structure of this 6-axis robot. The UE4 will automatically create the class. There are two files created. The first one is the header file. The second one is the CPP file, implement file. Then we can write the content of the program inside these two files. After finish the file creation, a global rotation white ball will display at this place. And two programs, one global rotation .cpp, and another one is global rotation .h, will showing at the C++ location. Right now, the system handling the file of C++ creation. You can see the global rotation .cpp the program like this, and the global rotation .header the program like this. The program is still handling. You just wait until everything settles down. In the header, we can see the constructor a global rotation, and we can see the class named a global rotation, which is a actor class. The system prepare the CPP as well. The constructor a global rotation, colon a global rotation, bracket, and the curly bracket. Single instructions is primary actor tick dot we can ever tick equal to true. That means for every friend, every tick can operate it. If we want to improve performance, then we can remove these lines. But we still let it be here. Ready, showing and here. So after global rotation created, first at the header will find a place, a public, suppose down here under the constructor, to define several classes. The first one is scene component. Press press enter. You sing component, a blank space, start, and give a name, root. We'll define the hierarchy. So in here we have the allowance U property. Bracket. No need a column at real. After the root using component, we'll define the first static mesh by using U static mesh component. Start and give a name fn0, which is the foundation of the loba. The same we have to announce U property. Bracket. Right now, define edit anywhere. Okay, after fn0, the rest of the set, let's copy these two lines and blank space down here by using Ctrl V to copy them, and fn1, Ctrl V, and fn2, Ctrl V, fn3, Ctrl V, fn4, Ctrl V, fn5, and Ctrl V, fn6, Ctrl V, the last one, fnt. After the class announced and public name, we'll go to .cpp to define the hierarchy structure. Before go to .cpp, if we want to use static mesh, and in here we have to include a header. Named component. And static mesh component dot header. Then let's go to .cpp. To define the scene component and static mesh. Where to write these programs, we can see the constructor sets default values. So we write under this line. The first one will define the root using create default sub object lower mark using component. Greater mark and give a name by using text and the bracket and the quotation mark. The name is root. At the end, adding semicolon. This is the root component. Next, use create default sub object as well. Let's copy. To create fn0 equal to create default sub object. And this one is static mesh. Component. And the name showing an editor is fn0. Now we define the parent and children relationship by using fn0 minus greater attach to bracket fn0 attached to root a semicolon at the real. Then we can copy these two lines for rest of fn1, fn2 until fnt's program. So fn1 create default sub-object static mesh component. Text fn1. fn1 attached to fn0. Then fn2 can copy these two lines and add here. Control V. The fn2 created default sub-object static mesh. The mesh name is fn2. fn2 attached to fn1. Control V. fn3 create default sub-object use static mesh. The name is fn3. fn3 attached to fn2. Control V. fn4 create default sub-object. Name is fn4. fn4 attached to fn3. Control V. fn5 Control V. The last one. Control V. fnt. The robot can download from our company's website. Then you can follow the step like this to write your own C++ program. Okay, then the header and the .cpp file handled. That's compiler. By pressing Ctrl Shift and B3 keys pressed together, the program will compile for you, showing down here. At last, the result will showing. And the button. Okay, one succeed. Let's go to the editor. To see the editor. Okay. The editor right now we use File, New Level, choose Default Floor, and pick the floor. Change the Z height to 0. And in here you can see the robot rotation. Press the left button of the mouse and drag this ball to the viewport. In here, this location, is minus 2A0, minus 2A0, 0 position. If we want to change to 0, 0 position, we just pick this 0 and press this button. The 3 position all becomes 0. You can see the global rotation Fn0 until Fnt, and the hierarchy structure F root until Fn6. Fnt should be the child of N6, so the program must have some trouble. Let's change Fnt attached to Fn6 and Ctrl Shift B, compiler again. As compiler succeeds, you will see an editor. This will automatically change it for you. In here, you can see root, but in here, you cannot see root simply because at the dot header, the root we didn't announce anywhere. But the structures, because of the you properties announce, the Unreal Engine will automatically generate the hierarchy structure for you, as well as the global rotations, static mesh. Right now, it's no use. Let's close the folder. But we still not see any components showing on the viewport. Let's see the Fn0, because the static mesh allows none. Let's set Fn0. For Fn0, you can see Fn0 showing on the screen. Fn1, Fn1, Fn2. Press the triangle. Choose Fn2, Fn3. Pick Fn3, Fn4. Press the triangle. Fn4, Fn5. Pick Fn5, Fn6. Pick Fn6, Fnt. Pick Fnt. The Fnt has to change to 0, 0, 0. Back to the correct positions. Every static mesh, the pivot points located at the original of the wall coordinates. Now, a hierarchy structure showing on the viewport. This created by C++ program. And let's close the file. First, we save the current. The name is difference. Give a global map 1 and save it. Okay, before we leave the lesson 2, we have to close the C++ file, cross all the file, and the files exit to cross C++ programs, and then file save all, and the file exit to cross the editor. Then today's lessons finished. We will have the lesson 3 of the actor rotating about the accurate pivot point. If you feel interesting about this lesson, please subscribe. Bye-bye.